Hi everybody, welcome to Education Alchemists YouTube channel. The following video is Rod Angood interviewing Professor John Fothergill discussing digitalising maths, science and engineering education.
I'm Rod Angood, Managing Director of Education Alchemists. Today I'm talking to Professor John Fothergill, a renowned electrical engineer. John, Education Alchemists have been working with international clients, delivering, amongst other things, Carpe Diem and E-tivities events. We know that you have used and deployed the principles and models within these approaches, and we would very much appreciate a scientist and engineer's perspective on them. So can I ask the first question? It has been suggested that some disciplines are less suited to digital learning, such as maths and science and perhaps engineering. Do you agree from your experience and research?
Well, I suppose I should tell you a little bit about where I came from when I started to do this.
That'd be good.
I'd been a lecturer in engineering for some time, and then I became Dean of Science, and after that I became Pro-Vice Chancellor, which is like the equivalent of Vice President these days. And one of the problems was that I really wanted to continue to teach, especially in one particular area which nobody else could really take on, and it was very popular with the students. In fact, it was in the area of optical fiber communications.
Right.
And so I couldn't commit to giving the 21-hour lectures, at given timetable times, when I had lots of other commitments at university management level. So I was really forced in some ways into going down the route, but I was very surprised how successful it was. And I mentioned that this was a lecture course. It was given to second and third years mainly, and it was a sort of optional course, but most students did actually opt to take it because it was actually quite popular. And so my experience then was to basically convert that into a way that would be flexible for me, but without sacrificing any of the quality to the students. And indeed, I think the students enjoyed tackling it in a different way. It was nearly all done virtually online, if you see what I mean.
Yep.
It also gave me the opportunity in many ways to allow the students to work in different ways, which I think they found very useful to do, really.
Okay. And so a subsequent question, I suppose, is that it would be fair to say that your students really embraced that online opportunity, did they?
Yeah, I mean, they did. It was I was quite amazed, really. They really liked it. I think it has quite a lot of advantages. I mean, one problem with conventional lectures is you have to sort of chop your material into 1 hour segments, whether it wants to fit or not, really. And one of the nice things about being able to do it online was that you could alter the amount of time you spoke to that, and then you could give them a little bit of a few questions to solve online, so that you could ensure that well, they could ensure that they really understood it.
Yeah.
And they seemed to like that, and it was very, very impressive how they worked with it, and the feedback that I got from it.
That's fascinating. After you encountered the 5-stage model of digital group learning and the E-tivities framework, how did you go about using them in your teaching work?
Okay, so I mentioned that I'd converted some of the lectures to online forms, which was fine. And I'd also, we'd replaced the sort of conventional example sheets that I used to hand out. I don't know if they're always called that in other universities, but basically sheets of questions, and then you'd follow it up with sheets of answers later on.
Right.
I changed that to being the online version, and that was great because I could see how the students were getting on and how they were engaging and so on.
Right.
I also felt that if the students had to work together a bit on the material that I was presenting, that would reinforce it and get them to have a better understanding of the material that I was actually presenting.
Right.
And so we'd recently employed Julie Summon at that time, and I thought, I'll ask her. And she introduced this idea of E-tivities. Now, I'd heard from other people there was no point in having discussion boards on online courses because nobody ever used them. And so I put that to Julie, and she said, oh yes, you want to sort of follow this E-tivity approach. And I really thought it was quite interesting. So at the beginning, I was amazed actually that you had to start off at level 1. You know, I thought nobody's going to have a problem there. But actually, the first E-tivity I had was very, very easy. Really, it was for the students to introduce themselves. There was no sort of threats. They didn't have to worry about whether they were getting things right or wrong or anything like that. They could feel quite happy in the environment, really. And so it was almost trivial in many ways, but actually it did introduce them to using the discussion boards and things like that and getting them to work in groups. And then we gradually progressed. So the second E-tivity was after they'd learned a little bit about fiber optics. I think they just learnt a little bit at that point on light receivers or something. And so I asked them as a group to work out, I don't know, how fast you could transmit data or something that was down an optical fiber. And it was almost like a bit of a competition because you could see group members coming in saying, oh, I found one that goes even faster than that. That was really good. And then we got on to later on, and we asked them to do a little bit more serious research at that point. And they had to, but they were still doing analysis at that point. So they'd got the knowledge that I'd given them through the lectures and what they could find out either in the library or on the internet. And they then used this to analyze what they'd found to give me the answers to those questions. But what I was evolving into from through these, I actually had 4 different E-tivities I really put them through, was that eventually they had to end up actually not just analysing stuff, but actually producing new stuff, designing stuff essentially. And so there was one, for example, one E-tivity was, I said, right, I found this little isolated island. I think it was at Bouvet Island, somewhere in the South Atlantic, somewhere near the Antarctic Circle. And I said, for some reason, they needed to connect this up to the nearest land, which I think was South Africa, about 1,000 miles away or something like that. Anyway, I basically I gave them some specifications. I asked them to design, what they'd need in terms of an optical fiber system in order to do that. So they couldn't look that up. They actually had to go away. I mean, so working your way from, I suppose I call it from sort of analysis to design, is a very natural thing to do in engineering. And so I found it was very useful from that point of view. And I think, go back to your question, which is, can it be applied to engineering and sciences? I think yes, very much so. I always valued my time in the laboratory, though, I must admit, both as a student and as a researcher. And I don't think, I wouldn't think that would be at all easy to replicate.
No.
But having said that, I have supported laboratory work and indeed design group activities in engineering with some of the online principles. And so I think you can certainly easily replace sort of many of the lecture courses which have been traditionally given.
Right, that's interesting.
Yeah. So does that answer your question?
Yeah, it does indeed. Thank you. And the thing I got from that is actually that the students kind of enjoyed the engagement. I mean, the notion of a competition is kind of an interesting one in itself, isn't it?
Yeah.
Okay.
I was going to say one of the nice things about doing group work online, one of the problems you always have with group work when you don't do it online is you never know whether you've got some sleepers in the group who never contribute anything.
Yeah.
And one of the nice things about doing it online is you can actually see the individual contributions of each.
Yes, of course.
Each, perhaps chase them if necessary.
Yeah. Well. Yeah, that's interesting. And did you feel your role changed? Did you become perhaps more of a learning designer rather than a teacher?
Well, I'm not really sure I understand what a learning designer is. Sorry, that's my physical sciences background rather than a social sciences background, I suppose. But I certainly carried on being a teacher. I certainly during the when the course was being run, I certainly had to be online. Well, I tended to pop online at least for 10 minutes, quarter of an hour a day, and I'd also promised to be online for a longer period than that on 1 or 2 days, which could change according to my schedule. So I was certainly still a teacher, but I know what you mean. I suppose what you're trying to say is, have I designed the course more? Well, I suppose academics tend to design their courses, of course. Yes. But I suppose that once I got it designed, well, it wasn't set in stone, because I could actually, I have 1 or 2 bits where I could change it. It was, I suppose, facilitating the course to run. But I wouldn't like to think that I'd sort of moved away from being a teacher. I still had a lot of interaction with the students individually as well.
No, of course not. And I would expect nothing more from an academic of your standing. Of course, you want that to happen. But I guess what E-tivities does is provides another dimension in which you can and your students can operate when it's appropriate. That would be fair, wouldn't it?
Oh yes, definitely. And it means the students start to engage with the material right throughout the course.
Yeah.
And I think in physical sciences that's really important, because you tend to build one concept on the next concept on the next concept.
Yes.
If they didn't understand it at the beginning, they certainly won't understand it later on.
No, right.
And the activities are great from that point of view, in the sense that it's a succession of activities that you've put in place. I say taking them from very fundamental stuff right through to having to really think on their own feet.
Right. Excellent. And finally, John, how successful do you think those approaches have been? I mean, what has been the impact on your students through this exercise?
Okay. Well, a couple of things. Of course, I'd run the course as a conventional lecture course for a few years before that as well. And one of the things that I noticed was that the distribution of exam marks really increased. So that, when I say distribution increased, I mean the marks increased.
Right.
And I can't think of any way in which the questions were easier. I just think it was just that they had genuinely understood the material much better, really. So there was a marked improvement in the exams, and with virtually nobody failing, which was unusual in engineering.
That's interesting.
The other thing, I suppose, is that the student feedback was excellent as well, and the students themselves really liked the idea. They liked the flexibility, funnily enough. And
so that's interesting too. So they enjoyed the experience. They did better as a result of the experience. I fear asking an academic whether or not the dropout rates changed, but was there any indication that that was better?
We had one person drop out during I don't know how often I ran it. It must have been getting on for 10 years. So I don't know, hardly anybody dropped out, basically.
Right, okay, good.
Yeah. So I think it was very successful.
Excellent. John, it's been absolutely fascinating talking to you.
Fine.
We thank you so much.
Okay, fine. Thanks very much.
Thanks a lot. Bye-bye now.